Next function on the stack is the push operation. So the function is to add an item to the top of the stack. We have seen that any element can be added into the stack or taken away from the stack only at the position which is known as the top of the stack. So we have to add an element to top of the stack. For that we will be using a function called as push. The precondition for that push operation is that stack should not be full. If the stack is full, we cannot place an element into the stack. So the precondition should be stack must have at least one space to hold that new element. Okay. Then the post condition, that is after the execution of this function, the condition of the stack becomes an item is added to the top of the stack. So whatever we feel to add to a stack will be added to the top of the stack. So let us see the algorithm for adding an element or a push operation. We are passing two arguments into the algorithm, s and an element. Element is the value that we wish to add to the stack, to the top of the stack, and s is the pointer to the stack. If s is a pointer to the stack, you know that the structure representing the stack will have some elements or members. That members can be accessed using this pointer with an arrow mark. Previously we have defined a stack to be having two members. One is the array called as item and the other is top for representing the index value of the top location of stack. So along with these elements we will be using the stack pointer s. So we are passing the stack pointer and the new element to be added to the push algorithm. So first we are checking whether we have a space for this element to be placed into the stack. That means if s top equals max minus 1, what is the condition? If s top is, or the top of the stack is referring to max, index max minus 1. We have defined max as the size of the array representing stack. So when the index value starts from 0, the final value of the stack will be max minus 1. If top is max minus 1, then the stack is full. Then we will print as overflow stack is full. We cannot do any operation on this stack now, and we will be going to step 5, which is the end of the algorithm. So for checking whether the stack is full, we are checking the top location to be equal to max minus 1. Or else we can use the algorithm for stack full also, because we have written the same statement there again. Is it not? So stop, if stop is equal to max minus 1, we cannot do anything. We are going to the final step of the algorithm. Otherwise, if stop is not equal to max minus 1, control will be passed on to the second statement. What we have to do? We have to increase the value of the index. Stop represents the index of the current top location. That has to be incremented by 1. So stop becomes the new location. At that location we can place the element. So s arrow The element space will be represented by array name with the index, that is S arrow item S arrow top equal to element. This is a member, item is a member, as well as this is also a member. Top is also a member and item is also a member. So along with these two members, we have to use the stack pointer. S arrow item within square bracket we will be referring the index value S arrow top, which is equal to element. So this element will be stored at the new top location. Thus we have inserted a new value at the top location of the stack. So we are printing a message accordingly that value is pushed onto the stack. So this is the algorithm for pushing operation. We have to pass two values. One is the stack pointer and another one is the new element, and we have to check whether the stack is full, that is we are left with any space in the stack for accommodating this new element. If it is not possible to accommodate that element, we have to stop the algorithm. Otherwise we will be proceeding with these steps. What are these steps? We have to increment the top location, and for the new location we are assigning the value of element. Thus the new value is posted on the top of stack. This operation is called as push operation. So for the push operation, we have to increment the index first, then assign the value. I repeat, we have to increment the index value, that is top is incremented first, then element is assigned for push operation. Now let us see the next function, that is the pop function, which is used for removing the topmost element in a stack. So this function removes and returns top item from the stack. Precondition is that stack should not be empty. If stack is empty, it will not be having any value in it. So we cannot take out any value from an empty stack. So precondition is that stack should not be empty. And post condition, after removal of the of an element, we will get the top element removed and the next element becomes the top of the stack. If there is only one item in the stack, after removal the stack becomes empty. So here what we'll be doing is that we will take out one element, and after that we will be decrementing the top index. In push operation we were incrementing the index first and assign the value. Here we will be taking out the value, then decrement the index of top. Let us see the algorithm. Here we will be passing only one value, that is the pointer. S is the pointer here again. So for the pop algorithm we will be passing the stack pointer S, and we will be checking whether the stack is empty or not. The empty condition for a stack is that top value of top element or index is -1. If it is -1, we can conclude that the stack is empty and we cannot take any value from that empty stack. So that we have to stop proceeding with this algorithm. If it is the empty case, we will be displaying underflow stack is empty and stop the algorithm. Otherwise we have to pop this topmost element. So we are using a variable popped here, and popped is assigned with the value. Which value? Whichever value is lying on the top location of the stack. That is value at the top index. So that is represented as S arrow item within square bracket index value S arrow top. So with that, the element here is being copied onto the variable popped, and we are decrementing the top index by 1, S top equal to S top minus 1. Then we are returning this assigned value, popped value, we are returning to the calling algorithm. So the difference between push and pop is that for push operation we are issuing two arguments, the stack pointer as well as the item to be added. For pop operation we are issuing only the pointer of the address of the stack. In the push operation we will be checking for overflow, that is whether stack is full. In the pop operation we will be checking for stack empty. In the push operation we will be incrementing the top index first and then assign the value. Here we will be taking out the value first and decrement the index value. So that is push and pop operation. Besides this, we have a peep operation also. It is nothing but we will be displaying the top element. We will be taking the top element and display it, but the top index will not be altered. So after this operation, peep operation, the stack will be as it is. Elements will not be altered, or top location will not be altered. So these are the 5 operations available with stack. Which are they? Is full is one, is empty is another, then push operation for adding an element, pop operation for taking out an element, and peep operation for seeing the final or topmost value in a stack. We have two conditions here. One is stack overflow and the other is stack underflow. Overflow is that when we are attempting to add a value or push a value onto the stack which is already full, we call it as stack overflow. Whereas stack underflow is that when we are attempting to remove a value from a stack which is already empty. Both these conditions are not at all possible. We cannot proceed with these statements further.